So this is our MSE 2001 mini project 2 by Alyssa Murphy, William Carlton, and Lucas Deal.
What is a polymer? Polymers are large molecules made from smaller, repeatable units called monomers and are commonly used in consumer products including packaging, textiles, and construction. Non-biodegradable polymers. Many commonly used polymers such as polystyrene or polyethylene are non-biodegradable by design, which causes them to remain in the environment for hundreds to thousands of years. When they do break down, they often create harmful microplastics. Biodegradable polymers. Due to the environmental impacts of traditional polymers, many scientists have worked to formulate biodegradable polymers like PLA or PHA in order to combat these issues.
Stress strain curves are developed through tensile testing and can be used to determine various mechanical properties in a material. The curves can give information about the toughness, yield strength, ductility, and more of a material. Stress strain curves can also be used to compare the mechanical properties of different materials.
It is hypothesized that when biodegradable or green polymers are compared to their traditional counterparts through stress-strain curve testing, the green polymers will exhibit lower toughness, lower yield strength, and lower ductility. This can be reasonably hypothesized because the bonds that make up these polymers should be easier to break, since the goal is for them to be more easily degraded in the environment.
So just to go a little bit into our procedure. So at the mill, we used the Mark 10 tensile tester to develop stress strain curves for different plastic grocery bags. We used one that was made of traditional non-green polymers like low density polyethylene, and then one that was a biodegradable green grocery bag made from PLA. We cut strips of our bags and then placed them in the grips, which is position 4 on this picture. And the Mark 10 basically applies a strain by pulling the grips further apart that will then allow us to get a stress strain curve. And then here's a picture of our group, all three of us, using the Mark 10 at the mill. Here's what it looked like our non-biodegradable bag looked like in the grips. And then here was the stress strain curve that showed up on the computer there. So then to go into our data a little bit, we were able to export the data from the Mark 10 into a CSV file and then regraph our stress strain curves using Excel. So here was the stress strain curve for our traditional Publix bag, and then here was the stress strain curve for our reusable bag. So then to just analyze this data a little bit closer, for our traditional grocery bag, the Mark 10 was able to tell us that the maximum load experienced during the strain was 12 newtons. And then the area underneath the curve, which represents our toughness, was 872 newtons. And then the slope at this linear area, which depicts the elastic modulus, was 0.8465. And our final strain at failure was 108.4 millimeters. For our green grocery bag, the maximum load was much lower with 5.4 newtons. The toughness was only 256.9 newtons, so a smaller area underneath this curve. The slope at the linear area, it may look similar, but there's a pretty big difference in the axes here. It was only 0.6032, and then the final strain was only 66.41 millimeters. So, based on this data, we were able to prove our hypothesis. Since the max load was less for the reusable bag and the strips were made to have roughly the same cross-sectional area, the ultimate tensile strength of the reusable bag was lower than the tensile strength for the traditional bag. And then based on the area underneath the curve, the traditional bag had a greater toughness, like we hypothesized. And then based on the higher strain at failure, the traditional bag was more ductile. Additionally, the traditional bag had a larger slope in the elastic deformation area, so that told us that it was more stiff. And then just to kind of conclude, reusable bags are becoming more and more popular due to pollution concerns. However, their biodegradable nature creates some mechanical differences in the material compared to more traditional non-green polymer materials. Overall, we saw lower toughness, lower ultimate tensile strength. It was more brittle. So there's potentially more engineering to be done here to create a more perfect comparison. However, it's obviously still good to use these reusable bags for basic grocery needs since we're not going to be carrying anything super heavy, and these are a better choice for the environment.